in Lecture 1, Part 3, we're going to do an introduction to Zylabs, look at comments, errors, and the Java language in general. So let's do a mini exercise and evaluate what the program output for the given program will be. In general, anytime you see a green banner, that's going to be an exercise, and it's a good idea to pause the video and attempt to figure out the exercise for yourself and then check to see if you got the same answer. All right, let's see how this program executes. So we have a public class called hello. We have a method in that class called main, which is normal, and then we have a print line statement which says Dear R. Kelly, and then a print line statement with a comma, and then a print statement saying have you, and a print line statement that will print lost your freaking mind. So if we remember, print line will print the string in quotation marks and a carriage return following the last item. So this should be Dear R. Kelly and then carriage return. We'll see if we're right. Let's move this down. Dear R. Kelly, yes. And then we should have on the next line a comma with a carriage return. Yep. And then we should have you, but notice we didn't use a print line. Rather, we just used a print statement. So that does not give a carriage return. So the cursor is going to be left at the space just past the U, which means the next print line statement should begin just after the U, which means both of these should appear on the same line, followed by a carriage return. And it does. Programs in Java consist of one or more classes, and each of these classes that would contribute to a program are stored in separate files with the file name matching exactly the class name. Each of these classes must be compiled. However, oftentimes in programs we will make use of the system class or the scanner class. Those sort of classes do not need to be compiled. Only the classes that you write and have created .java files for. Once you've written a .java file that consists of a class, it is compiled and is made into a bytecode file which has the extension .class. So when you write the code, you'll write it in a .java file. When it's compiled, the compiler will generate a bytecode .class file with the same name that you have given to the class and the file. This .class bytecode file is the runnable file which can be ran on a Java virtual machine. To be clear, when we say programmer, we're talking about one who writes a program. Users are those who interact with a program. And programmers are often also users. Another term we're going to use pretty often is library package. So a library package is a library of classes that are packaged and pre-written, and you may use them in your code to do a lot of things so that you don't have to write it and figure it out for yourself. A good example of that is scanner or the system class. Otherwise, you would have to figure out how to interact with the low-level components of the computer yourself. But it's great that Java has pre-written classes to do that for us. A programmer is a person who writes code. So we didn't say anything about how good the code was. We didn't say anything about whether or not they kept their job as a programmer. They may be just sitting at home writing code for themselves. They're still a programmer. However, a good programmer, and you could sort of insert there an employable programmer, is one which writes code that is reliable, readable, and reusable. Reliable code, every time you need it, it does what it's supposed to do. It's sort of bulletproof, no matter which user uses it, no matter if they don't use it in the same order. There's not a lot of holes in the code that make it so that it's tricky to use. So no matter who uses it, it seems to work, which makes it sort of bulletproof, is how it's often referred to. Code that's readable, when you look at the code itself, it's easy to understand and maintain. Let's stop there. It's easy to understand. Why is that important? If you've written code, you may think, well, I'm going to compile it. It's going to become bytecode. And then I've made my program, So like, let's say I keep referring to Excel. So let's just go with Excel. You may think, well, I don't need to know what the code behind Excel looks like, and I don't need to read it. That's true. You don't. However, someone at Microsoft is tasked, and not someone, there is a team at Microsoft is tasked with maintaining and fixing Excel. Because Excel is not perfect, no program is perfect. There will always be bugs and there will always be problems. So it's someone's job to fix bugs and add features. They have to build on the existing code to be able to do that. This is what we mean when we say it's maintainable. So as the ecosystem changes, as new problems arise, they're able to maintain the code and it's able to continue and progress. That is not possible if the code isn't readable in the first place. So good style comments and proper decomposition that makes sense are what contribute to readability. And then good code is reusable. So reliable was all about that it should do what it's supposed to every time we need it to. Readable is about that when we actually look at the underlying code of the program, we can make sense of it and understand what's going on, and we can maintain it by other people. Other people can maintain it, not just the person who originally wrote it. Reusable means that your code isn't written in such a way that the components of it are so specific they only have one use. So let's say that, and we'll look at this a little more, but let's say that I was writing code for a robot to turn on a light switch, okay? Then theoretically I should be able to write that code general enough so that I could tell it whichever light switch I want it to turn on, and that same code could have the robot turn on a light switch in the hallway, turn on a light switch in the kitchen, by me saying something like turn on light switch kitchen, turn on light switch hallway. That would be reusable code that wasn't so redundant. However, let's say that for every light switch I had to write a different program. Well, that's not very reusable. That's sort of redundant. I'm having to tell the same instructions how to interface with a light switch over and over and over again, and that's not good code. And that involves properly decomposing the overall problem into pieces that make sense and provide this level of reusability. So that one may make less sense to you, but you'll understand as we move forward. In an effort to help make code more readable, most programming languages contain comments. And a comment is something that is for human eyes only. It has no bearing on the code itself. It will not be executed. It doesn't change anything about how the code executes. All that it does is give documentation to whoever is looking at the source code, or whoever will be looking at the source code. So in Java, the way that you document the code is there's two ways, three, but we won't talk about the third immediately. There's two ways to add a comment in a Java program. That's // and /*. So let's talk about that just a little bit. For a single line comment, // is typically what you'll see used. So right here, as soon as this carriage return occurs, this next line would no longer be inside the comment if this were code. The /* is a comment start that does not end at the carriage return. So when the carriage return occurs, the next line is still part of the comment, and everything is part of the comment until it encounters a star /, which is the opposite of the beginning characters. So anytime in a program you see /*, you know that it's starting a comment, and that comment goes until you encounter a star /. So here's a one-line comment using the // method, which ends with a carriage return. So this line right here is not part of the comment. And here is a multi-line comment using /*, which is then terminated using star /. So this is two ways to go about commenting code. Either is acceptable. Typically, I use // simply because I find /* to be a bit annoying. I don't know. It's just a personal like or dislike. There's not a right or wrong way here. You can use /* to do single line comments. I see that fairly often as well. It's entirely up to you, and either is acceptable. Where should comments be placed? Well, at the top of each file, you need a comment header, which includes name, date, course, and section number. And you should include a description of the program. Also, and as you get into program 0, as we go through program assignment 0, you'll see this. It should include the honor statement. And the template that this says will be supplied is in programming assignment 0. So intend to reuse the template that you see in the top of programming assignment 0. At any location where you need to explain complex pieces of code, you should find a comment, or you should use a comment. So let's say that you enter into some very complex math. Let's say for some reason you needed to figure out the minimum distance between an arbitrary point in space and a fixed line. Well, that's going to involve taking the derivative of the distance formula of the line and that point. And, if someone saw that in code without any comments, they're just going to think that you're going math crazy. So you would really need to include comments to explain what you were doing and why you were doing it, so that when others come behind you, they don't think, this is unnecessarily complex, I'm going to delete it. When they delete it, the code breaks, but it's their fault and your fault, because their fault that they didn't look into it enough to understand it before they deleted it, your fault because you didn't document it enough so that they could read it easily. So document any sort of section of code that has any significant function to it. And every method should have a dedicated comment. So above every method, you should write a comment. And we will say more about that. But follow examples that you see in the lecture and in the Zybook material, in the programming assignments, as well as your textbook, the Regis textbook. You may think that personally comments are annoying and time-consuming to have to type, and something that you wish you didn't have to do. And I would understand that. That's how I felt about them initially as well. Everyone does. However, yes, in a classroom environment, they may seem tedious, but this is about learning to be a good programmer. If you're working at a job and you don't comment your code, you probably won't keep that job very long. I made that mistake one time early in my career. I wrote a lot of code that was improperly commented, and it had to be completely rewritten. And the reason was, as the code grew and grew, I stopped understanding exactly how it all worked together. And that happened because basically I had 1 month to do 3 months worth of work. And when you rush, things happen. And so I imagined that I could get away with not commenting in a rush, and it didn't work out. Comments help you. as your code grows and becomes complicated, it may be difficult for you to remember and understand exactly what it was doing to begin with. Comments will be invaluable to yourself. Comments help others as well, because in real code that is not part of a classroom environment, they help others by them being able to understand code more quickly without having to pore over every line to attempt to understand exactly what you were attempting to do. Comments help others in this class because they they help you in this class and they help others in this class. They help you in this class because they get you a better grade, but they help others in this class because when a TA begins to look over your code, if they have no comments, then they're not likely to quickly understand what you're doing, and that's likely to frustrate them. So it's going to help others to prevent them being frustrated, but it's going to help you because you won't lose points. Comments help with debugging. So if you want to temporarily remove a section of code from your program to test to see if perhaps that is where the problem is being introduced, a good example of this would be if you were wanting to figure out which lines in a program are causing an error. You may be able to comment out a section of the code by placing that code in a star or /* comment, and by commenting it out, the compiler is going to ignore it, and if the error goes away, well, then you've probably found the area that your error's in. So they can help you with debugging. Comments help your grade. I already alluded to that. If you don't comment your code, you're going to lose points. And for more on that, refer to the style guide, which is on Brightspace. And as I already said as well, employers want them. My boss wasn't very happy when that occurred, but I learned and grew and never made that mistake again. And I have warned many people since then. If you have to rush, don't rush by leaving out comments. This is a fairly good example of the commenting style that we expect to see from you. At the top, we have a comment block using the / multi-line comment method. And then inside the main method here, we see that we've used single-line comments. So at the carriage return, the comment is terminated, and we return to non-commented statements. And these single-line comments are being used to communicate what function the following section of code has. So what I mean by that is this comment tells us that this section of code prints out the first verse. This comment tells us that this section of code prints out the second verse. And that's really a good commenting style here. So you're going to have some block of statements that accomplish the task that the comment says it's accomplishing. So all of these statements together work together to print out the first verse. Then there's white space left. That's important. Leave white space in between inappropriate ways, like just as in this example we have, so that the ordering of the code makes sense. So we've got a first verse, the code that then prints out the first verse, and then the second verse, and the statements which print out the second verse. So this is good commenting. Consider this to be an example of what we expect from you. So far in the example programs, we've primarily made use of the print line statement. However, we don't just want to print things. In a lot of situations, we want to be able to get input from users. So someone typing into the terminal, we want to be able to get access to what they type in. So let's say we want the user to enter their age. So at the beginning of the program, first of all, to get access to what the user types, you must import java.util.star. So there's a comment here, a single line comment following that statement, which tells you what that does. It gives access to helpf library methods. Okay. At the start of your main, you're going to have to include this statement, scanner keyboard. We'll talk more about what each piece of this statement is later, but right now what you're doing is learning to mimic this particular thing that we're telling you. Even though you may not understand exactly what this statement does, understand that overall what it does is give you access to the user's input. So type scanner space keyboard equals new scanner system.in. Okay. Now keyboard will be used to get the input from the user. So when we want to read the user's age that they type in, we will say int age. So we're storing it into a variable called age, and we'll talk more about that a little bit later. And then to get the input and put that into age, we say keyboard next int. So keyboard.nextInt. That's how you would read in the age from what the user has input to the terminal. Now, in time, you will come to understand each piece of this statement as well as the following statement. But for now, understand that this is the method to get access to the user's input. So this is an example program that shows how when we do what we were discussing in the previous slide, which is to get the user's age, and then we want to display it back to the screen. So first of all, you have to import java.util.star, which gives you access to the utilities class. So we discussed that previously, but this is step one. Second, we've made a class, which we've called input example, and our main method called main, at the very first line of the program, or very first line in the method, it doesn't have to be the first line in the method, but it needs to be before you need to make use of it. We have to make the keyboard scanner object by saying scanner keyboard equals new scanner system.in. So that creates the keyboard object. So then, to prompt the user, we print to the screen, how old are you? Now notice, we're using a print command, we're using a print statement, not a print line statement. Therefore, the cursor is going to remain at the location after this space. So the cursor will remain right here. And you can see that in the sample run. So it prints out, how old are you? And then the user begins to type, and it shows up just after the space following the question mark. So then we're going to get the age that the user types in using keyboard.nextInt. So here we're making use of the keyboard object to get the user's input. And then we're going to print that out using a print line statement. Now, this is going to be an important extension of what we've shown previously using the print line statement. So we have a string which is surrounded by double quotations. That's what we've seen before. Then we're going to use the plus operator to combine age, which is an integer, with the string, and then use another plus operator to combine another string with the resultant string plus age. So this is a way to be able to print multiple things in a single print line statement. You can use the plus operator between strings and numbers to be able to combine them to print them using a single print line statement. So, how old are you? The user types in 45. This is a comment just so that you understand where the user's interaction came in. Then we print you are, which is corresponding to the string here, you are, and then age, which is 45, which is what they typed in. So when they typed this, we use the keyboard object to get what they typed and store it in age. And then we have printed age, which contained 45, and then we print the string years old. Hopefully that makes sense. Let's move forward. One of the most frustrating things about writing programs, I guess when you begin, it becomes just part of the natural process of programming as you get used to it. But in the beginning, one of the things that's frustrating is programs are always incorrect when you first get done with a draft. There are exceptions to that, but they're very few and far between. You're going to write a program and then you're going to test it, and it's going to have multiple flaws. These flaws are introduced from two main sources. Number one, you incorrectly coded it. So errors in the code. That's one source of flaws. The other source of flaws are you coded it properly. There's no errors in the code per se. It's just that logically what you told the computer to do will not accomplish the task that you wanted accomplished. So you had a logical flaw. Both of these are your fault. Computers only do exactly what you tell them to. So if you tell them to do something that ultimately won't solve the problem, that's your fault. If you don't tell it to do what you intended to tell it to do, that's also your fault. So the process of programming here, sort of in a nutshell, you come up with a solution and code the program. Now, one of the things that is suggested when you're attempting to figure out how to solve a problem, how to come up with an algorithm to solve a problem, don't do that in front of your computer. Think about it and go over how to solve the problem using pen and paper on a walk, somewhere other than in front of the computer, because typing the program in as you think about it, sort of ad hoc programming, will work for simple tasks, but as those tasks become more and more complicated, you need to spend more time planning and conceiving the program than you do actually writing the code. So once you have come up with a solution, it is time to type in carefully a Java program to accomplish that solution. Once you have it fully typed in, you're going to compile the program and attempt to run it. So here there will be many errors come up. When you compile it, there may be syntax errors. If you have all the syntax errors fixed, there may be logical errors or runtime errors, and you will have to correct those. Then repeat steps 3 and 4 until the program works as you intend it to. So devise the solution, type the code, try to run it, get the errors, and then fix the errors. Repeat this attempt to run, fix the errors until no errors and you get the result you want. That's the typical process for programming. Step 4 from the previous slide was get a bunch of errors and fix them. So when we get these errors, we usually refer to errors as bugs. And we refer to the fixing the errors as debugging. So debugging the code is really what step 4 is all about in that previous model of the process of programming. So what sort of bugs, what sort of errors are you going to run into? And I alluded to this already, but there's 3 types of bugs you're going to have, 3 types of errors. Syntax errors, which is where you broke the rules for a language. So you didn't use the right punctuation, you didn't end the line with a colon, or a semicolon, sorry. You didn't end the line with a semicolon. You didn't use a period operator to access the system.out.println. You instead use system comma out comma println. Any of these would constitute a syntax error. You didn't follow the rules of Java, the correct grammar for Java. So the compiler is just going to basically puke and say no. That is the first type of error that you're going to encounter. Second type of error is a runtime error. Runtime error is something that the compiler won't catch, but as the computer begins to execute the program, it's going to do something that the computer itself considers illegal. A good example of this would be, let's say that your program takes input from the user and divides it by the next input from the user. So, the program says, give me a number, and they say, okay, 4. And then they say, all right, give me the number to divide by, the computer says to the user. And the user says, oh, I know, I'll be funny. I'll say I want to divide by 0. Well, that's going to make the computer, it's going to make the program crash. So even though your code didn't have any syntax errors, you allowed the user to enter something which would ultimately cause the program to fail because it broke some sort of rule the computer had in place. So one of those is you can't divide by 0. So the program is going to crash while it is running. In that situation, the way you would fix that, where the user gets to enter things and divide by them, is you would need to have in the program input validation, where you check to make sure that the user didn't enter 0, and if they did, you would say, I'm sorry, you can't divide by 0, instead of attempting to perform that operation. So you're going to have syntax errors, you're going to have runtime errors, and then you're going to have logic errors. A logic error would be you actually didn't plan the program correctly. So you followed the rules of Java, and you prevented runtime errors, potentially. However, your solution still doesn't accomplish the result that you want because the plan that you devised to solve the problem was insufficient or incorrect. So, if you were attempting to make a calculator program and you were not using the built-in math functions, and a user typed in 2 plus 2 and got 5, that seems to be a logical error. So an interesting story regarding computer errors referred to as bugs. First of all, problems have been referred to as bugs as far back as 1878. There's a correspondence between Thomas Edison and one of his associates, where he refers to bugs, which are little faults and difficulties, he says, in his inventions. So bugs, the idea of referring to problems as bugs has been around for a very long time. But in 1946, Grace Hopper was working as a member of the Harvard faculty. Actually, Admiral Grace Hopper, she was an admiral in the Navy, was working for Harvard as a faculty member in the computation laboratory with the Mark II computing system. The Mark II computing system was based on relays, not the modern transistor. One day there was a problem with the Mark II, and the researchers searched through and found that the problem was there was a actual bug stuck in relay number 70. And so you see in their documentation here, because they actually taped the moth to their logbook, and they inscribed below it, first actual case of bug being found. So they were already used to referring to small problems as bugs, but in this particular case, the bug was a bug. Actually, this logbook entry is now in the Smithsonian Institute. And Grace Hopper would often recount that story. Here are some tips to help you minimize errors. So number one, when you come up with solutions to some problem and you're conceiving and designing classes, algorithms, and methods, do so with great care and think through them completely and all the implications that accompany them. When you begin to code, take great care to code it into Java the way that you intended it to be coded. So as you translate between your idea of how to solve the problem and the code that you write, make sure that translation happens well with great care. 3, if you're multitasking, doing multiple things at the time that you're trying to program, watching TV, having a party, whatever, that's going to probably introduce a lot of errors. So try to minimize multitasking so that you can focus on the code that you're writing. If you wait to the last minute, it's going to be problematic and you're going to have very little time to debug your code. And yes, if you were to give access to your computer to people who may or may not understand and take care with how they use your machine, then yeah, they may introduce problems as well. So in this class, we're going to use the IntelliJ IDE. So an IDE is an integrated development environment. So this is where you type and compile and then ultimately run the Java programs. So IDEs exist for most programming languages, Python, C++, so forth, and they're invaluable tools that help speed up and consolidate the process of developing code. So soon we'll begin to use IntelliJ to write your Java programs, compile, and run, and then to debug the programs as well. It's sort of similar to Eclipse if you've heard of Eclipse IDE, but in some ways I think it's a little bit better. But for the moment, we're going to be using the Zylabs development environment to write your code, which is built into the Zybooks system. On Brightspace, you'll find instructions under course resources for installing the IntelliJ IDE. It's important that within the next couple of days that you install IntelliJ and go ahead and have that environment on your computer. So now let's shift and talk about programming assignments. So programming assignments are housed in the Zybooks environment and they are stored in Chapter 12. So in the course calendar, you have 3 programming assignments due each week. You have 1 week to do each of them. So that means there are 3 simultaneously assigned programming assignments each week. It is your responsibility to access Zybooks and do those programming assignments on time. Any help that you need must come from TAs or myself, the instructor. If you need help, set up a meeting with a TA or email myself and attempt to set up a meeting. So we're going to go over how to do a programming assignment by going through programming assignment 0. So in general, you need to read the specs, develop the program. So this is similar to what we talked about before. Understand the problem. That's what reading the specs is. So understand what you're trying to accomplish with the program. Then devise the program that you imagine will accomplish that task. Then code it and debug it. There's a certain number of submissions you're allowed for each of the programming assignments, and it'll tell you how many you have and how many you have left. So be careful that you don't use up all your submissions. Okay? You don't have to submit it to test the code. You can test the code without having to resubmit. So make sure that you're testing your code. Once you're confident, submit. We will take the highest scoring submission. So if you submit 6 times and 2 of them worked pretty well, but the 4th was actually a higher scoring attempt than the 5th, then we will take your fourth submission as the submission to be graded. Now, Zylabs will pre-grade it for you. However, we will also do a grading pass to check for style. So documentation, proper program decomposition, and your grade will not only be based on the functionality that Zylab tests. Program assignments are going to be graded within 7 days. That's the attempt. So hopefully we'll be able to stick to that. So this is the view that you'll have when you log into Zybooks. It should be. And you are on the Welcome tab. On the bottom right here, you see that we are on the Welcome tab, and so the book and its various chapters are displayed. Chapter 12 is called Programming Assignments - Zylabs. So we're going to do Programming Assignment 0. Okay, so first of all, we would read what is expected. So understand the problem, understand what is being asked to do. So first of all, it says add the required documentation, and I was highlighting to show. It says to adjust the comment block below. Okay, and push your ViewNet ID into this field, and this will be the template that you're to use for any future programs. In CS1101, the section, there's only one section, so it's not very important, but it is section 2. Today's date. And then the honor statement is already there, which is the academic conduct policy statement. So make sure that you have read the academic conduct policy, because you're certifying that you have. And then here you should include a program description. Okay, so now let's look at the instructions continuing from where we left off. So we did the add required documentation. So at this point, the instructions say to click run program and test to see what the output is. Then we're to type in 2 in the input box and run the program, and the output should be 4. Then we're to type 3 in the input box and click run program, and it'll give 6. So this is incorrect, but we're going to submit it anyway to show what happens if you submit incorrect code. So we've skipped ahead to input 2 into the original uncorrected program. Produces 4, which is the correct output. Now we're to type in 3 and submit, or type in 3 and run the program. So notice here we're in develop mode. In develop mode, we're able to enter a number and click run program, and it runs the program using the number 3 as the input to the scanner object. So basically, the number 3 is what is being typed into the terminal by the user. And then we're clicking Run Program, and it runs the program using that as the input. In a moment, we're going to switch to submit mode, but I wanted to make note of that. So develop mode is where you should be as you begin to write and debug code. So here we've typed in 3, and it's supposed to give us the square of 3. Oh, nope. So our code is incorrect. So, but we're going to submit anyway because we feel confident, So click we're going to change to submit mode. We're going to submit for grading. So we got 0 of the test cases correct. So the reason we got none of the test cases is because the white space did not match. So you may think that is trivial, that, there's a different number of following or leading white spaces in the results. However, that is not accurate. If you include an extra carriage return or an extra space, that causes your output to deviate from the expected output, and Zylabs is going to consider it wrong. That may seem tedious, but this is part of developing attention to detail and precision that is necessary to be successful at writing computer code. So while I agree it is somewhat tedious, it is necessary, and it is an important skill. So even though the output was close, it needs to match it exactly. So what was missing was a new line. So we're going to change back to develop mode and enter the change from print to print line, so that we'll have a carriage return after the output, which is what the instructions told us to do, to change it to a system.out.println line. Now we're to try 2 again. It produces 4. Now we're to go back to submit mode and submit for grading once more. So notice here, previously it showed that we had an error in the white space following the output. However, now that's no longer an issue. So we got 1 test case correct. So input 2 created the correct output 4 with the correct amount of white space. However, for an input of 12, our program output 24, which deviated from the expected output. So our program is still not correct. And that's how you should read those test cases. Look at the test cases to understand what has gone wrong. So we earned a +1 point because we got 1 test case correct, but the last 2 test cases failed. So right now we're only receiving 1 out of 3. So we need to change back to develop mode. And we're going to adjust the bug. So in this case, the bug was that we had used a plus operator to attempt to square the numbers rather than using a star operator. Star operator is the multiply. So at this point, we have successfully submitted the code. It was correct using the star operator, and we have full marks shown right here, 5 out of 5, with a green check showing that it is complete. On this first one, make sure that you continue until you get 5 out of 5. There's unlimited submissions, so there's no reason to not get full marks on this programming assignment 0. However, keep in mind that TAs will will also be grading the Zylabs. So even though you may get full marks for the functionality portion of the grade, if you did not correctly adjust the comment block at the top, you would lose points for that. So there's no reason to lose those points. Those are almost clerical. However, they are important, so we will enforce that. But if you lose those points, it really should not occur. It's simply a matter of putting the time and effort into properly commenting your code. So syntax errors are grammatical mistakes. So just as in English, there's a proper grammar, there are things that are governed by rules in the English language, and if you break those rules, you are using improper grammar. Similarly, in Java, there are syntax rules, and when you do not follow those rules, those grammar rules, you are committing a syntax error. These are very strict. There's a very precise way in which things are to be entered into the Java programming language, and deviating from that will generally cause a syntax error. The compiler will catch these syntax errors and display error messages telling you what you've done wrong. It's very helpful. Also can be very annoying. So examples of what would constitute a syntax error: if you use a period where a program expects a comma, that would be a syntax error. Also the other way around, if you use a comma where a program expects a period, that would be a syntax error. If you do not end a statement with a semicolon, that would be a syntax error. If you have excess or not enough curly braces, that would be syntax error. If you use an identifier, which is a protected word, so for instance, if you attempt to make a variable named int, that's a protected illegal identifier, and it will cause a syntax error. If the class and file name, so when you create a class, it must be named the same as the enclosing file. If that's not the case, that would again be a syntax error. We've talked some about runtime errors already. They occur at the point where the computer is running the code and something happens which the computer considers to be illegal, and this will cause the program to immediately terminate, which is called crashing, and the computer will ideally display some sort of an error message. So examples of things which would cause a runtime error is if the code attempted to divide by 0, that would be a runtime error. If you attempted to access a memory location that didn't exist. So if you had a string that was 3 characters long, it had the word car in it, but you attempted to access character 5, then that would create a runtime error because there does not exist a memory location 5 in the string that you are dealing with. So in general, runtime errors are easy to know that you have because they are going to occur after compilation. So you have compiled the program and that went okay, and then you began to run it, and it's not that the program didn't work correctly. That's not how they show their heads. It's that the computer crashed and the program terminated unexpectedly. You may have encountered this in some available programs that you've downloaded from online or different sources. Sometimes your computer will come up and say a program terminated unexpectedly. On Mac, it does that. Would you like to send an error report or something of that nature? That's a runtime error usually that the program still has. So even professional grade software will often encounter runtime errors for various reasons. So runtime errors and syntax errors are precisely defined. A syntax error is something that breaks the grammatical rules of the language, and a runtime error is an error that causes a program to crash or terminate unexpectedly. Logic errors are less precisely defined, but we will define it in the following ways. So, first of all, yeah, it's true. You could consider almost anything to be a logic error. A syntax error, you could say that you failed to understand the language and therefore it was a logic error. A runtime error, you could argue that the reason they occur is because you failed to understand how the user may interact with the program, and the computer may interact, or the program may interact with the computer, such that runtime errors may occur. That's true, but the way we will define logic errors is as following: those which are not detected during compilation, they do not cause the program to crash. So we're saying a logic error is an error that is not a syntax error and is not a runtime error, but it produces incorrect results. So there is an output, but it's wrong. So again, going back to the example we did with programming assignment 0, we had logical errors in that we did not include the right amount of white space following the output, and we used the plus operator instead of the multiply operator. Those are logical errors because they produce output, which is not detected during compilation. It did not cause a crash, and it produced the incorrect output. Another example would be if you were attempting to calculate Fahrenheit from Celsius by multiplying by 1.8 and adding 23 instead of adding 32. That would be a logical error. So syntax errors and runtime errors are easier to find and fix because the syntax errors will be given by the compiler. They'll tell you, hey, you have a syntax error. Runtime errors are shown by the computer crashing or the program crashing and the computer saying, hey, you have a runtime error. However, logical errors have no such detection systems. So the only thing that you can do to find logical errors is to look and attempt to figure out why you're not getting the result you expect. Searching for these logical errors can be frustrating, and one of the tips that seems to help most people find them more quickly is if it seems that you're having trouble finding the source of a logical error, walk away from the code and come back after you've given yourself a little bit of time so that you can look at it with fresh eyes. What's happening is when you have been programming something for a significant amount of time, you begin to see what you expect to see rather than seeing what's actually on the screen. That sounds odd, but it's true. And by giving yourself some time away from the screen, when you come back with fresh eyes, you see it more clearly and you're able to find these logical errors with less frustration and typically much more quickly. So this is the end of Lecture 1. Make sure that you access the Brightspace page and are aware of any and all assignments that are due. So any Zybook activities or any programming assignments, and familiarize yourself with the Brightspace environment and all the course resources. Read the academic conduct policy because you are responsible for it, and at the beginning or in the header of each program you will be asserting that you have indeed read and understand the academic conduct policy. Also, go ahead and install IntelliJ IDE and have that installed on your machine for when we need it in the future.